right, let's take a peek at the quiz. Okay, so the 10,000 students at a Polytechnic University were surveyed here, and we have a table, so a two-way table with all of our totals in the table. So what's the probability that a randomly selected student is in a master's program given that the student is not enrolled in the science program? So just to write that in notation, you are in the master's program given that you are not in the science program. So what we want to do is just find the correct rows and columns. So we have you are not in science, so that means you are either in math or engineering. So we have 6,300 people in math, in engineering, and 2,100 in math. And then out of those, we want to see how many have a master's. So we've got 1,890 there, and we've got 630 there. So we want to add those up. And then doing the math, you just want to add those together and divide. So 1,890 plus 630 is going to give me 2,520. And then 6,300 plus 2,100 is going to give me 8,400. And if I divide those two, I'm going to get my answer. So that's going to be 0.3. or 30%. So option D here is going to be the best one. For question 2, we are looking at fire stations and their ability to see if incoming calls require medical assistance. So there's an 85% chance or a probability of 0.85 that we require medical assistance. So question 2 is asking, what is the chance then that they will not need medical assistance? So needing medical assistance, probability of that is 0.85. So the opposite of that, not needing medical assistance, remember little c means complement of, so opposite, is 0.15. Because these two things should add to 100% or should add up to 1. So 1 minus 0.85 is going to give me 0.115. So the best answer here is B. Lastly, it says, assuming independence, so one call is not going to affect or change the odds of the next call needing medical assistance. It says, what is the probability that exactly one of the next 2 calls? So we have 2 calls coming in, and we want one of those to require medical assistance. So either the first one can require assistance and the second one doesn't, or the first one does not and the second one does. So since these are independent of each other, I can just multiply these. I don't need a tree diagram per se because I don't have multiple options. I've just got kind of one thing happening with its opposite. So I have 0.85. The first call would need assistance, and then the second one does not. And then the first one would not need assistance, but the second one does. And so I just want to get those 2 options. So 0.85 times 0.15, either way is going to be 0.13 if I round. And then if I add those 2 together, I'm going to get 0.26. Now I rounded a little bit, which is why I have a slightly different answer, but that's going to be B. I rounded these. But if you don't round, then you would get exactly B. I rounded a little bit. So that is the second option. So these being independent, you don't need to branch everything out on a tree. You're just looking at this event coupled with another event, this and this. So then we can just multiply them and get our overall probability.